And yeah, thank you guys as well for staying awake. And I want to thank SideFX for having me again, especially Fiona, who brought me into this collaboration, which is really great. I'm happy to be able to do this. And yeah, what we'll be talking about today. So we'll be talking about adjacency workflows. There were a few other things I was exploring since I started working on this collaboration. I had certain chunk of time to create this, and originally I had much grander ideas about how to mix it in with also the machine learning. I'll mention it later as well. I was lucky to have a support on SideFX Slack from Jeff Liat and also Jakub Pringler, who were walking me through some of the things and pointing me to maybe paths that were not as clever to do. So yeah, and originally when I started working on this, I was using the Houdini big head, which is very simple geometry. It has relatively nice UVs, but then I realized it would be cool to stress test these adjacency workflows on geometry that is far more complex, doesn't have UVs, and it would kind of push me to figure out maybe where are the issues people can come across this. So let's start. Courtesy of 3dscans.com, I found this lovely statue, and it comes in like triangulated, very dense, not really clean mesh. I just scaled it down in the scene and find some post that would work for me in this in a 0 position. And then using the quad remesh, I created some relatively low poly compared to the original, but still high enough to have a good density and remain the detailed geometry. So the first step was to create some arbitrary UVs. In this case, I used the UV unwrap, which gives me this basic layout. And it sort of works. One of the things that I realized working in Copernicus is that you really want to utilize the UV space that the layout gives you. So here, if I would be using the UVs as they are and creating all the intricate detail, it would be so tiny that it would be sort of rasterized to a low resolution, even when I was using 4K to 4K space in the Copernicus. So jumping ahead a little bit, working in Copernicus and assigning different noises, I was getting this issue which was really bugging me, and I couldn't figure out where is these imperfections coming from. And later on I realized that it must be some of the UV islands being overlapped. That's one of the things you wouldn't have to deal with if you manually create nice UVs, or you would have someone who's creating like a perfect UV layout on a geometry. And luckily, Houdini does have, from labs, it's a lab node, it isolates the overlapping islands and sort of distributes them into your layout, so you can avoid this issue further. And then to properly propagate the UV islands, I use the UV layout, just enabled spread islands to all available space, and it gives me this relatively good sort of distribution. So one note at this point, with because further we will be working with the adjacency nodes, the gap between the UV islands will essentially give you how much space you have before a certain operator will cross the boundary. So it's good to have some gap between the islands, but in this case I left it as tight as possible, so I would be potentially avoiding more issues and stress testing the setup. So next step was to flatten the geometry into UV space. The reason for this is, in my mind, I wanted to spread sort of dips of paint on the statue from which the spreading would be happening. So in this case, I'm sort of flattening everything and then using simple scatter to give me some sort of color information. I'm using simple expression and also matching the changing ID for the color. So this is the layout before it goes into Copernicus, and Then I created just, CopperNet and start diving into it. As you can see, the UVs is really bad, but the adjacency nodes that are coming in Houdini 22 will crunch through it just fine. So we bring it into Copernicus. I bring in the points in the flattened UV space and also the geometry. We have the preview on the 3D geometry, and I'm just using stem points to essentially scatter like a simple circle on the statue. And this is essentially the adjacency nodes that are coming in. The one I didn't get to use was the adjacency space transform. Other than that, I had a chance to test everything else. Not that it's not useful, but in this case, I just didn't have a really use for it. So let's bring the adjacency in. We have our geometry coming in, and geometry to adjacency will give us this information. In a nutshell, it is a packed cable with much more fields. And in general, I would recommend doing a little bit of research on how cables work in Copernicus. It's really useful, especially if you'll be working with, blocks or other solvers. So here you can just bring in cable unpack, and when you click the, set fields from input, it'll give you all this information you can later on work with. So let's have a look how we build this spreading effect that will essentially drive everything else in the whole simulation. Now I'm going to make one pro tip. By complete accident, if you press X when you're in Copernicus, it will switch between flattened view and the 3D preview view, which doesn't seem like a big deal, but if you have a large network, it's such a pain-free way to preview between those two. Super useful. So this is the, let's say, custom solver that's driving the spreading. In this talk, I will not be diving too much deep into how block works. There's better tutorials on that, especially here from Alex as well, or Jeff Liat online. So for all purposes, I'm just using the incoming color, which is our BGA with alpha. Those are the yellow inputs. And then we have the pass-through, where we're feeding in the adjacency. The naming and indexes is arbitrary. You can name it whatever you want. You just need to set the fields properly. So the green ones are cables. So they are passed through on each iteration, in this case, each frame. So we don't need to recalculate them. And they are not changing. Adjacency is not changing every frame. So this way we will save computational time. And as an overview, it's just about each frame. We will add the sourcing color that is dipping onto the statue. And then by using slope direction and adjacency distortion, we'll achieve this sort of spreading noisy effect. So if we look at the most simple portion of this solver, it would be just the circle shape that is spreading outside thanks to the slope direction, and the adjacency distort already, takes care of bridging the UV islands just fine. But this would be a relatively boring effect. So we want to bring in some noise. As you can see, it's not properly mapped. So in this case, the adjacency distort at the very end would still correctly bridge the islands without seams, but the way the distorted color is happening would be sort of messed up and crippled by this incorrectly mapped noise. So this is where we want to use adjacency attribute sample. By default, it is sampling position attribute, and this way we can feed it into the noise and map it correctly. So now the incoming value that's going into the slope direction is distorted, and instead of getting sort of like a boring circles, we're having nice organic pattern growing outside. Because we are working in RGBA with alpha, we are previewing the overall area of influence. So if we want to preview how things are going to be blending together, we just need to, multiply it with the alpha. And this is the resulting effect. So next step for me was I wanted to mix up the colors a little bit. And for this, I just used the information itself to offset some values in saturation and hue shift. So I'm essentially remapping value from minus 180 to 180. And over time, it's creating this lovely effect of really bright and juicy colors. We also have the alpha that's coming from the setup and the overarching clipping mask. And all of these things will be later used in the material of building the final effect. So next step, I wanted to create some kind of like a leading edge for this effect. And originally I built like a solver again, and I was doing some dissipation over time. And then I realized, great, Houdini 22 is coming with some time manipulation nodes, which is really useful. So I just offsetted the frame by 10 and subtracted it from the original map. And this way I get this really nice sort of leading edge effect that would drive other effects later on. Speaking of the time manipulation, we have time shift, time blend, and time loop. Essentially, it works like a SOP level operators. And in this way, you can potentially hold first and last frame or loop the animation and sequence. And I think it'll open up quite cool, things we can do in Copernicus later on in combination with solvers and other stuff. So now I'm going to talk about blurring. And I think there was one question earlier today about blurring. So obviously, I have my edge and I want to do some masking, multiplying, and then creating maybe more delayed effect of this leading edge. So if I just blur it out of the box, the blur node will cross the boundaries of the UVs, not respecting any sort of adjacency. But we can bring it into block and utilize the adjacency in a way to solve this issue. So essentially, you need to find small enough value for the blur not to cross the boundary, and then by using a certain amount of iterations in your block, you can find a value that you wanted to originally achieve. So in this case, it's like 500 iteration, but I don't know, it was like 4 seconds for it to cook, so it's not that crazy. And this way, I was able to multiply, subtract, do some basic operations, but every time I needed to blur something, I had to put it in a block and do this sort of process. So it is a little bit like annoying, but it's not that expensive in computational time. It's just a blur. And then originally I had this idea to create some sort of reaction diffusion effect that's sort of following this color spreading. And by complete accident early on in exploration, I came across this Turing pattern, courtesy of Alex here. It's really fun. It's similar to reaction diffusion, but it works slightly different, and you can achieve different results as well, depending on what color information is going into it. You have some options that I set the way I need it to be. And essentially, we are passing through the adjacency again that goes into the adjacency. And I'm using the spreading mask information to mask the Turing pattern so it doesn't spread beyond the mask because with a lot of iterations, it could grow quite quickly. So we just wanted to keep it in the area of interest. Just out of curiosity, reaction diffusion and some other solvers in Copernicus do have adjacency embedded in it, so you can utilize it. And as you can see, you will have no issues with any UV seams. And again, I wanted some more exciting colors, so I used the same principle, just offsetting the hue shift and saturation. And then I went to testing Ripple Solver. So now you can do kind of like in SOP level, you have a Ripple Solver here. It works really well. It computes fast. The only change I needed to do, because usually Ripple Solver works with like initial value that starts sort of rippling away, I'm just using add to add the leading edge each frame, so I'm kind of sourcing new ripples as the spreading effect happens. And because I'm adding each frame, I want to clamp it so we don't go above the value of 1. There are some basic settings that I adjusted, you know, conservation, waves, and spring, so I have the effect roughly how I would imagine it to dissipate. And at the end, I wanted some sort of dissolving effect that would bring the color back into its original simple plaster material. I was doing some, again, like a solver, and then I realized, yeah, I can just invert the original animation, and it's going to give me this nice blending effect. Now, honorable mention, Nicola was talking about the grunge notes. I'm super excited about it because these are the presets I was always dreaming of having, and now, you know, all of us can use materials, and no material will be the same. You can allow editing and dive inside, and because they are built by, you know, Copernicus native noises, you could sort of match them with adjacency nodes. So this way you can have like seamless, you know, grunge textures for any object. In this case, I haven't done it because there's quite a lot of steps for every one of these nodes. So I just faked it and used like an adjacent material, but it was such a small detail, and I mixed it up with some MTLX material noises that you can't really see any seams anyway. And then I brought it into Solaris, so it's a straightforward setup, 1 camera, objects in material library. We have three materials for each of the objects, and I'm using linker to sort of assign them. Same with lights, material linker, you know, assigns lights for specific objects or excludes them. So I have the lighting exactly as I want. And aside from some minor issues, I had really fun time working with Karma and Solaris, so I would love to explore it more. Yeah. Here's a little sneak peek into the material layout. And as Fiona mentioned earlier, you will have, you know, access to everything in the HIVE file, so you can kind of explore it. I'm not going to go over the material. It's pretty much the same as, you know, Redshift or Octane principles. And here's one more time the overarching simulation. Originally, I wanted to figure out a way how to sort of separate the spreading effect by ID for each of the colors, and then each of those spreading islands would have like machine learning pattern growing on top of them, but I was a little bit naive on how much time all of that would take. And speaking of machine learning, I'm going to point to Jakub's presentation again. He mentioned the adjacency there, but just as like a little example, you can just, you know, use a simple pattern, train it with the default values, and you will get something like this. And as you can see, the preset already has the adjacency input in it, so you can just feed your adjacency, and using the spreading mask in a mask by update, you can affect the ML training, so you can get this gradual effect. It's pretty exciting. And that's it. So thank you guys. And yeah, any questions?
That's lovely. Okay.
Thanks, Jakub. Great Thanks. Presentation. I was wondering, there is some way to bring inside the block the time shift and use it as maybe some sort of time displacement, as in After Effects or something like that.
That's actually a good idea. I haven't tried it, but I would imagine you should be able to do that. So yeah, maybe I'll do a test with that as well. It's a good idea, because you could potentially loop maybe with the source of the color or whatever you would work with. Yeah, that's a good idea.
Okay, cool. Thank you.
Somebody else? So,
did you have to bake any of the texture, or are you reading them live from COP?
That's a great question. I had to bake everything because in 4K it's massive. Yeah, it is heavy. I think someone here earlier was explaining the unloading the cache for Copernicus. So that's something I also had to figure out. I had a lot of crashes before I realized that. Luckily, I had like almost 400 gigs of RAM, but even with that, it was pretty
like
tight.
everyone else.
Yeah, exactly. Just flexing, you know.
Did anybody have any other questions? Okay.
Yeah, there's one in the back, in the darkness.
Okay.
Thank you. So I was just wondering, why do you have to quantify the topology?
Why do I have to quantify the topology? If I remember correctly, when I left it in the triangulation, there were some areas that were like so dense and messy that the UV unwrap was giving me some sort of like issue, or maybe I think it was like cooking until it crashed. So I think that was the reason why. And also it's like cleaner topology. So yeah, don't have an exact answer. But I remember it was not liking the the triangulated mess.
Hi, it's all really exciting stuff. It's you're talking about the size of the textures. Is it possible to work to a low resolution size and scale up later effectively? Do you get similar results, or is it a bit? Is there a lot of difference between what you'll where you'll actually end up?
There will be different. So, for example, do you see these like a nice little pattern happening here? So, if I wouldn't apply the UV layout that sort of spreads the UV island, so I'm using as much of the UV space, the edges of this would be super rasterized, because in the texture, if you look at it, it's like really tiny and there's not enough pixel information. In terms of the 4x4 resolution, I just wanted the quality of the image be really high, so I can do these macro, shots, and everything is really clean. But you can run it in just, 1024 by 1024. Everything will work the same. You just want to have a clean result, essentially, because it's not vector, it's just rasterized pixel information.
Yeah, so I was just thinking for when you're developing and running through sort of various versions.
Yeah.
Thank you.
Okay, I think we have, we gotta wrap up soon, but we have Flip Plushie. So who can name the 3 time-based cup nodes? Okay, I have to go back up there. Put his hand up first.
Time shape, time blend, and time loop.
Woohoo!
Okay. I think that's it. Thank you very much, Jakub.
Thank you, guys.
And thanks, everyone. Oh.